Hey everybody, it's Ryan Berg here. We're here live in Austin, Texas at that new design to make them lighter, faster, easier to work with, or more ergonomic. So to display one of the new applications that we have is our new line of remote cutters. So we have actually underground and overhead remote cutters. And what I want to show you here, first and foremost, is our underground remote cutter. And this would be used for confined spaces, or when you're working with a primary where you can't necessarily understand what type of voltage is on the line, or if there is voltage, or if that line is live. So this would be a situation where you're combining a couple steps, making it a little bit more succinct and a lot safer than historical practices. So I've got my remote control here. You can see I've got a Bluetooth connection with this tool. The light is blinking. And we're just going to do a real short demo on how this remote tool works. So I'm just going to let the tool get a hold of the cable, and then I'm going to act as if I'm getting out of the confined space, and we're going to let it go. So as you can see, I've got a solid green light. That means the blade's all the way in its resting position. It's all the way through, and the cable's severed. So I wouldn't necessarily be able to see this tool doing its job, so this remote control is really important to let me know what's happening in that confined area that I'm not a part of. And then the big thing is I've got complete control of it. I can back the jaw off. So that's our underground remote cable cutter. We also have a overhead remote cable cutter. And what I'm going to do is I'm actually going to go through this pairing process. The remote is looking for something to pair with. This tool is looking for a remote. They're going to sync up here in a second, and I'll get a solid blue light. That means that I've got a good Bluetooth connection. And that'll just take a second to make sure that that pops through there. There we go. So you got a solid blue light, and I've got a blinking light on the top of here. And here's where Rob's going to come in handy. And we're going to act as if we're cutting a piece of ACSR from a remote distance. So that blasted right through the aluminum. It went right through the steel core of that piece of ACSR. I believe it's 336 is what we just went through. But again, that's keeping the person that's working in that energized area away from voltage. It's using a fiberglass standoff or hot stick to do that job. Thanks, Rob. So a couple other things that we wanted to touch on. One of the really neat ones that we've been working on for about 2 years is we're trying to impede voltage from getting where the source is when we're making a connection, or when we're cutting a cable, or when we're working in energized areas. We've come up with a innovation that ultimately impedes voltage from getting to where you may be working with energized equipment, or energized, you may have an energized cabinet from something not being grounded correctly. Ultimately, what we're doing, we're rated for 1,000 volts to stop that voltage here, and then have the user would be placing their hand here with their appropriate PPE. So we just wanted to show you a little bit of a demonstration on how this works. So what I got here is a standard piece of A and B building wire copper, and I'm going to place it on the bottom and the top of this test stand, and you can see that there's an arc coming through there. So there's 10,000 volts running through this. There's no current going behind it, so it's not necessarily dangerous. But what we've got here is an example of how we achieve that barrier for voltage reaching where the user is holding the tool. So we've got an extended screw that goes here, and this goes right into the pump housing. And then ultimately, historically, we would have seen a circuit because there's metal contact all the way through that. But with this new innovation with our insulated line, you'll see that this is really anticlimactic, but there's no circuit. And just to kind of show you, it's still running. So again, that's the other part. We want to keep that voltage away from the end user, give them another line of protection, as opposed to just their PPE, their gloves, everything else that they would be using. All right, one of our favorites, one of our newest. We call this tool the Micro. And historically, we've been using this tool for small ferrule terminal type crimping applications. We've just come up with a new blade style that can get through a whole bevy of different materials, whether they're zip ties or whether they're ACSR, small ACSR, copper, fine stranded copper, aluminum, all sorts of different materials. So ultimately, we can just kind of take a look through here. So it just went through steel and aluminum at the same time. So as opposed to using a hand tool over and over and over again, that repetitive motion, it really kind of wears on the body. It's a key contributor to carpal tunnel syndrome. What we've done here is where you would typically see a hand tool or a pliers that would be used on a regular basis, cutting through hard materials or clamping down on a regular basis. That hand strength that's needed, like I said, is a key contributor to injuries. What we've done is we've taken that hand strength, which is typically around 200 pounds. That'd be a really, really strong individual, kind of like a rock climber. But we've taken that down to 6 pounds of pressure with this tool by simply pushing down on that trigger. This tool achieves almost 5 times the overall grip strength that you would have versus a lineman pliers. In addition to that, we got one more. And what you're seeing on the screen here is a good example of what we continuously do on an ongoing basis as we develop tools. All of these tools have went through a very similar process to quantify how much energy it takes to actually use the tool. So as you can see on the screen here, this was a situation where we went down and helped out a small utility in Knoxville, Tennessee, to help them quantify what they're doing to their bodies on a daily basis. And they found out about us because we do this with the design of our tools. And so what you can see with these two 12-ton tools is we have our legacy tool here in the front, and then we have our new version, which has went through this process in terms of ergonomic topology, balance, and making sure that we're ultimately positioning the weight of the tool in the best spot for the user to really be able to control the tool well. Some of the comments that we've got when users are holding these two tools in their hands, they'd say, like, ultimately, this is like swinging an axe, this one's like swinging a sword. A lot more control, eliminating weight from the head of the tool through that design process that we use has really pushed some of this weight back onto the forearm and allowing much better control, especially on a tool that's going to be used in really tight confines, like a panel box or a transformer, pad mount transformer in the utility industry. So ultimately, again, here back at NECA 2022 in Austin, working with the Greenlee cable termination product line. Thank you.